questions here, I want to point out that 2b and 2e cannot be done without, or cannot be calculated without the quadratic equation. So when we look at this, it says, for each case, decide and state whether a solution would require the use of the quadratic formula. For all cases where you use where the use of the quadratic formula is not required, communicate the full solution. So I'm going to pause the video, get you to pause the video and try a few of these, and then I'm going to answer a few of them. Okay? So you might want to wait and give it a try. For A, it's got hydrobromic acid. Hydrobromic acid is one of the strong acids. So when it reacts with water, 100% of it becomes hydronium and bromide. And I know that it's a strong acid because if I look in my data booklet, up here, I've got hydrobromic acid is here. So 100% of that reaction is going to go forward. And so it wants the hydronium concentration of a 0.2 mole per liter hydrobromic acid. The concentration of hydrogen bromide or hydrobromic acid is 0.20 mole per liter. So will the concentration of hydronium at equilibrium, because all of it becomes that. For B, we've got predict the hydronium for 0.2 mole per liter hydrofluoric acid. Well, hydrofluoric acid is a weak acid, so the concentration of hydronium, we're going to only be able to make the assumption if the hydrofluoric acid meets our expectation. And hydrofluoric acid has a Ka of 6.3 times 10 to the negative 4. So the Ka equals 6.3 times 10 to the negative 4. So if I've got 0.20 mole per liter divided by 6.3 times 10 to the negative 4, this only gives me 317. The assumption doesn't work. And because it doesn't work, I don't want you to calculate it. You could do it with a quadratic equation, but it's not a requirement of this course. So then for the next one, it's 0.20 mole of ethanoic acid. And so we need to know the Ka of ethanoic acid. Ethanoic acid is also known as acetic acid. So acetic acid is here, and it's 1.8 times 10 to the negative 5 is the Ka. So the concentration was 0.20 mole per liter. If I divide it by 1.8 times 10 to the negative 5, I'll be able to determine if the assumption's okay. And this is going to be 27,000 or greater. And so the assumption works, in which case the hydronium ion concentration equals the square root of 0.20 mole per liter times the Ka, which is 1.8 times 10 to the negative 5. And so the hydronium ion concentration is going to be 1.9 times 10 to the negative 3 mole per liter. And if it asked for the pH, like it's going to in the next series of questions, I just take the pH equals the negative log of the concentration of hydronium, which is what I've got here. The only thing that I want you to be aware of here is that they've given you the concentration in millimole, so that's going to be 2.3 times 10 to the negative 3 mole per liter is 2.3 millimole per liter. Okay, so you can finish out those other questions, and hopefully this is going well.